Hi, everyone. My name is Sid Hackett, and my project was estimating emissions of geothermal technologies, and my mentor was Magnus de Witt. So, all right. So, bottom line up front, the purpose of my research was to develop a report on the greenhouse gas emissions of different geothermal technologies and to determine the implications of these findings on Alaska's energy landscape. So for a little bit of context, in 2017, researchers Annika Eberle, Garvin Heath, Scott Nicholson, and Alberta Carpenter of NREL published a report of similar nature. And in this report, they screened literature for data on greenhouse gas emissions of 3 geothermal technologies. So these were hydrothermal flash, hydrothermal binary, and EGS binary. And I'll kind of get into what all of this means in a moment. And they compiled all these values for analysis of emissions of each technology, also disaggregating by emissions during each life cycle phase. So during the construction phase of geothermal plants, during the operational phase, and during the end of life phase as well. And so my own research project goals were to build off of this NREL report by screening and collecting data from literature published since 2017, so since NREL published their report in the first place, and to analyze any emissions changes between the cases analyzed by Eberle and others and those analyzed by me. And so another goal was to use these results to determine ways with which Alaska can improve its electricity landscape and present all of these findings in one cohesive report. And so just to give a little overview of the different geothermal technologies that I spoke about, you can see here a diagram of a flash steam plant and a binary cycle plant, which are essentially two fundamental geothermal technologies. And so you can see the flash steam plant, the way it works is basically cold geothermal water is pumped into a very hot reservoir below the Earth's surface. That water gets heated up by hot rocks and it returns to the surface before getting separated back into cold geothermal water and into steam. And that steam spins a turbine to generate power before going through a condenser, which turns it back into geothermal water, so back into liquid form, and this cycle kind of continues on. And as you can see in the flash steam plant diagram, some of the geothermal steam is actually emitted from the condenser into the atmosphere, which explains some of the findings in my report. And so this binary cycle plant, you can see right here, what makes a binary cycle unique is that it consists of 2 closed loops. So this bottom closed loop has geothermal water running through it. So essentially it gets pumped into the ground, returns up to the surface hot, but this time it goes through a heat exchanger. And so what that heat exchanger does is it turns a liquid working fluid in this upper loop into a vapor, which spins a turbine, generates power, and then gets condensed back into a liquid. And so this cycle continues on and on as well. And so, like I said, the 3 technologies that I analyzed were hydrothermal flash, hydrothermal binary, and EGS binary. And so essentially the difference between hydrothermal and EGS is that hydrothermal makes use of natural reservoirs below the Earth's surface, while EGS uses hydraulic stimulation to fracture a reservoir below the Earth's surface. And this is often due to places with high geothermal potential, but low natural permeability. And so a quick overview of my research methods. There were 3 primary phases associated with the project and the development of my report. And so phase 1 was developing the data set, phase 2 was analyzing the data, and phase 3 was researching the Alaskan implications. And so developing the data set, I began by screening 169 pieces of literature against criteria described in the NREL paper. So some examples of this criteria are being centered around, or the papers being centered around geothermal energy in the first place, giving kind of numeric results, kind of things of that nature. And then the next part of developing the data set. So once I had all of these papers that had passed all of the screens, I then collected data from each one. So I collected parameters of the geothermal plants that they discuss, including the geothermal technology used. And I also collected estimates of greenhouse gas emissions in grams of CO2 equivalent per kilowatt hour for the total lifetime, as well as individual life cycle phases, if included, from each report. And so the next phase was analyzing this data. So I used Python's matplot library to create figures which convey the data and distribution of emissions estimates visually. You can see here there are many, many box plots that look like this in my report. And so another aspect of this was finding interesting trends to investigate further. So something kind of neat that I found was in many of the papers that I was using, the papers which passed all of the screens, they actually gave greenhouse gas emissions estimates for the Hellescheide hydrothermal flash plant in Iceland. And so I figured that given the fact that I had so much data available on this plant, I might as well do kind of a separate analysis of that one as well, in addition to the kind of overarching analysis I had already planned on doing. And so finally, I also researched explanations for these kind of findings from this analysis. So now phase 3 was researching the implications in Alaska. So this meant learning more about the energy landscape of Iceland and Alaska by reading various reports. The reason why I did research into Iceland is because it is an example of an Arctic country with an electric grid that has high redundancy and also relies pretty heavily on geothermal energy and other renewable energy methods as well. And then I worked to find ways that Alaska's electricity grid can take inspiration from Iceland's to kind of raise its redundancy as well. So you can see I have a map of the rail belt grid with a few potential additions overlaid. So things like pointing out geothermal sites or potential geothermal sites that are close to the rail belt, as well as a potential connection between Delta Junction and Palmer that would turn Alaska's rail belt into a loop to add further redundancy, kind of basing it off of the model of Iceland's ring grid system. And so a few key findings, you can see up here, I have the emissions broken down for the construction phase of each of the 3 technologies. And as you can see, between the pre-2017 data set and the post-2017 data set, the median emissions actually go down for all 3 technologies. And so this indicates that there have been improvements in drilling techniques in lowering greenhouse gas emissions during the construction phase of geothermal plants as a whole. And as you can see right here, I have the 3 kind of distributions of emissions for the geothermal technologies that I analyzed, up next to distributions of greenhouse gas emissions as reported by the Department of Energy of other energy generation systems. And so you can see that the median emissions for geothermal technologies kind of hover around the same values as other renewable energy technologies. So anywhere between 20 and 50 grams of CO2 per kilowatt hour versus the much higher emissions that come from greenhouse gas energy generation technologies like natural gas, oil, and coal. And so in conclusion, there were several key challenges to my project. Collecting emissions estimates from each paper was a process that was very tedious. Every paper kind of presented data in a different way. And so it was almost like starting from scratch whenever I would start reading a new paper. And additionally, there was kind of a lack of data on some new emerging technologies. So one thing I originally wanted to do in my report was analyze kind of these emerging geothermal technologies, things like magmatic geothermal, CO2 plume, closed loop. But the issue is that many of these new technologies are more kind of concepts than they are actually in practice at the moment. And so there's just kind of a general lack of data on those new technologies at the moment. And I tried reaching out to some companies that are kind of leading the way in these new geothermal technologies, but none of them got back to me. It is what it is. But anyways, I'd say overall this project was a success in my books. And despite these challenges, seeing all my work come together in the report was very rewarding. And even though this was a solo project, I really enjoyed discussing ideas with the other interns and with my mentor. I also started with very little knowledge on the subject matter and ended with what I would consider to be a pretty deep understanding of geothermal energy generation methods. And then finally, I learned a whole lot about the unique energy landscape of Alaska through this internship. I'm from very far out of state, and so this was pretty eye-opening for me, and it was a really, really cool experience. So that's all I had prepared. If you have any questions, I may have answers.
So your data came from papers.
Yes.
Is there a method you use to normalize differences in the presentation of the data from the papers?
So essentially what I did was the primary pieces of data I was picking out from each paper were or I guess I should say to start, the papers that I took were ones which explicitly gave emissions of specific geothermal plants in grams of CO2 per kilowatt hour. And some of them also broke it down to the emissions during the construction phase of this plant, the operational phase of this plant, or the end of life phase. And so for each of those papers, I would determine, what is the technology of the geothermal plant that they're presenting in the paper, and then what are the emissions values from this report. And so that's how I kind of compiled the big spreadsheet. But as for normalization, that was kind of outside of the scope of the work. If you look at one of my many spreadsheets, the parameters for many of the geothermal plants tend to be pretty different, like different depths, different temperatures, different locations, things like that. And so I didn't really normalize any of the parameters. I think I basically followed in the same process as the original NREL paper, where they did the same thing as I did, but kind of an opportunity for like next steps in this project would definitely be to normalize certain parameters. Yeah, that way. That answers your question.
Hey, this is Chandler in Anchorage. On one of the last slides you showed, it looked like there was you're showing grams per kilowatt hour of emissions from different technologies. It looked like there was a really big range in that emission intensity for the flash geothermal.
Yes.
Yeah, that one. Do you have an insight into what drives that range?
So once again, this actually what led to the hydrothermal flash kind of distribution being so large was, I forget the exact, I think it was I'm probably butchering the name, but the Bagnoli plant in Italy was what had very high reported emissions. And I couldn't give an exact answer for why this plant specifically had such high emissions, but from what I remember, it was just based off of specific parameters of the plant and kind of a lack of things like carbon capture and ways of mitigating the emissions in the first place. And so, yeah, it's also just really depends on other parameters that are just kind of individual to the site. But yeah, that's about the best answer I could give. I was also a little confused when I saw like how kind of wide of a range it was for hydrothermal flash, but that's, I guess, my best interpretation for the reason why.
Thank you.
And I have a bit of a follow-on question. This is Michelle in Anchorage. Thank you, great presentation. You may have there might not be enough data to do this, but did you see anything that sort of underlies trends between lower or higher emissions, like geography or depth, or like what are some of those parameters that maybe are pretty clearly related to emissions?
I didn't see based on any of those specific parameters, but I did notice there was a pretty substantial difference between the emissions of the different technologies themselves. So hydrothermal flash of the three had the highest reported emissions, and that was what I believe to be a direct result of here. I'll go back to the diagram. Oh, if it'll let me. Maybe I won't. But in hydrothermal flash, the one with the geothermal technologies.
Uh-oh, we can't hear you for a second.
Yeah, it's just
Like with the diagrams of the two earlier on.
trying.
There we go. This one. Yeah. So hydrothermal flash had higher emissions than the other ones, and you can see because non-condensable gases are actually emitted in this when you're using this technology, and it was higher than both of the binary technologies. EGS binary was slightly higher just because of the process of hydraulic fracturing, releases some emissions as well. But those were kind of the biggest factors in kind of separating what greenhouse gas emissions you can expect. That was definitely like the biggest thing that I noticed, at least.
Thank you.
Slight question, but so the tubes that are going down, is there like a holding tank at the bottom of the tubes, or do they connect?
Yeah, so essentially the way it works is that there is a reservoir of very hot water, and this can be like 5,000 meters below the Earth's surface, so very, very deep. And it has very hot water, and essentially you have the two pipes going in, or often more, but I guess for the sake of this, you have the two pipes going in. One of them is pumping in water, and then hot water is coming back up through the top one. But funny you say like a tank at the bottom. There's a new technology. One of the new emerging ones that I was hoping to include data on is something called advanced geothermal systems, which actually just is kind of one closed loop that goes all the way through, and just gets kind of heated up by the temperature of the ground rather than actually going through a reservoir of hot water in the first place. But yeah, in the case of EGS, where you're using hydraulic stimulation, it just goes through fractures in the ground. So yeah, that answers your question.
What advice would you give someone to read 169 papers?
Oh man, brace yourself. It was a process for sure. It's you kind of have to start from scratch when you're reading each new paper, because there's not really a standard way that they present their information. So really just learning to sit down and read each one in its entirety. And if they have the data, they do, and if they don't, they don't, and you move on. So yeah, that that's the advice. It's not easy, but it's doable.
Did you know anything about geothermal energy before you did this internship?
I basically knew that you pump water in, it comes back hot and spins a turbine. That's about the extent of what I knew about geothermal.